Assalamualaikum and good morning. My name is Fikhri Bin Abdullah. Today I would like to present my final year project. The title is TORREFACTION of farm biomass using limited air environment technique. My supervisor is Dr. Muhammad Faizal bin Hasan. For today's outline presentation is introduction, teacher review, methodology, result and discussion, and conclusion. So, why do biomass is cannot directly used as fuel? First is biomass has a high moisture content. Second is biomass also has the low calorific value. Besides that, biomass also has low feed carbon. So what is torrefaction? Torrefaction is pre-treatment process of biomass in an inert environment at temperature 200 until 300 degrees Celsius at atmospheric pressure that can improve biofuel characteristics. So why we use limited air environment technique? The large amount of inert gas increase the cost consumption of torrefaction. So for this study, we want to evaluate the performance of torrefied plant biomass produced by limited air environment for various temperatures.
The scope of study is temperature is varied from 250 degrees Celsius to 325 degrees Celsius. The performance is evaluated in terms of gross calorific value, moisture content, volatile matter, ash content, and feed carbon. Besides that, the residence time is feed from 30 minutes. And the comparison of the performance is performed with international benchmark as well as the raw plant biomass without torrefaction.
So for literature review, let me move to the slide. For the first literature review, the study was conducted by Ahmad to study the effect on properties of plant kernel shell and mukah balingan coal by torrefaction at different temperature at 60 minutes. The results show that calorific value and feed carbon of PKS increase while volatile matter decrease with increasing of torrefaction temperature. And the mass yield for torrefied PKS range from 88% to 65%. This is due to volatile such as hemicellulose and some salt lignin compound released during torrefaction. The energy yield decreased with the increasing in the temperature. The energy yield for torrefied PKS was drastically reduced to 65% at pre-treatment temperature of 250 degrees Celsius. Next, the study was conducted by Ja'far Rahman and Samsudin. Study the torrefaction of EFB. The torrefier was developed from a domestic 1600 watt electric oven. The rotating machine built inside the oven as an agitator for the biomass. The reactor was rolled a few times slowly to make sure the sample inside the reactor is distributed evenly. The calorific value for raw EFB was 17,500 kJ per kg and it increased to 18,820 kJ per kg after torrefaction. The sample increased significantly about 10 until 38% with the increase of torrefaction temperature. When the torrefaction temperature was 200 and 225 degrees Celsius, the mass loss was about 50 until 25%. Next, the study conducted by Chen. Chen conducted study of pre-treatment of wave using an enclosed reactor for torrefaction. The enclosed torrefaction tank with a solar collector to provide a stable heat source of 200 until 250 degrees Celsius. The sample is placed in enclosed chamber which is heated by solar energy. As the temperature in the chamber increased, after reaching the holding time, the vent valve was opened to release the pressure and all the waste straw in the reactor was quickly taken out. The results show when the temperature of enclosed torrefied increased, the calorific value feed carbon increased while moisture content decreased. Next we move to methodology. Here is the overall flowchart for this study. For preparation of raw material, firstly the PKS is grind to get the smaller size. Next, the PKL is shift to get size of PKS below 500 micrometer. Here is the sample after grind and shift. For torrefaction, the temperature is varied from 250 degrees Celsius to 325 degrees Celsius. Residence time is constant at 13 minutes. The diagram shows the reactor that is used for this process. The reactor is designed to limit the PKS from exposed to environment air during the torrefaction process. Here is the experiment setup for torrefaction process. The thermocouple was placed close to make sure that the thermocouple record the temperature reading of the sample. For calorific analysis, the bomb calorimeter is used to measure the value. For each analysis, 0.3 gram sample was used. Next, we move to proximate analysis. We use the front end for the proximate analysis. There is three analysis properties. First, the moisture content. The PKS is heated at 107 degrees Celsius for 1 hour. Next, for volatile matter, the PKS is heated at 950 degrees Celsius for 7 minutes. And for the ash content, the PKS is heated at 750 degrees Celsius for 4 hours. And here is the following formula is used to calculate the feed carbon content. Next, we move to result and discussion. Here is the result of analysis obtained for the raw PKS. It showed that moisture content is 10.15%, while volatile matter content is 59.8% and ash content is 30.91%. Feed carbon content is 15.9%, while calorific value is 14,684 kJ per kg. Next, this is physical appearance of PKS before and after torrefaction process for each temperature. The results show initially the raw PKS exhibit a brown color. After torrefaction, the color of the sample become darker. This is because the carbon content in the sample increased with increasing of torrefaction temperature. For the mass yield, the mass of the sample significantly decreased with an increasing of temperature. The higher the temperature, the lower the mass yield of torrefied PKS. This was due to volatiles such as hemicellulose and some short-chain lignin compound released during torrefaction. It can be concluded that the mass yield of PKS is affected by temperature of torrefaction. We move to energy yield. Energy yield is contribute the amount of energy released when the unit mass of treated product is burned and its product is cooled. The energy yield decreases as the temperature increases. This is due to the decreasing of mass yield. For calorific value, the calorific value increases with an increase of torrefaction temperature. This is due to the increase in feed carbon content after the sample been treated with high torrefaction temperature. The torrefaction improves the calorific value about approximately 28%. For proximate analysis, moisture content is slightly increased, which are 13.7% and 11.9% for torrefied temperature 300 degrees Celsius and 325 degrees Celsius. This is due to the improper storage of the sample after torrefaction. The sample absorbs back the moisture from the surrounding. And volatile matter show a significant reduction with an increasing of temperature. For the ash content, the results show the increase in its value. For the feed carbon content, it shows the increase from 19.31% to 29.82% with an increase of torrefied temperature. For the conclusion, we can conclude that torrefaction with limited air environment is an effective method that can improve biofuel characteristics of biomass. The torrefaction with limited air environment increase the calorific value. When torrefaction temperature is increased, the ash content and feed carbon content are also increased, and the volatile matter are decreased. For the future work, the amount of sample being analyzed for calorific value should be higher. If higher amount of sample be used, we may see a significant difference between each of the torrefaction temperature. The sample after torrefaction should be stored in improper container. The sample can absorb back the moisture from the surrounding. We want to avoid this. Here is my Gantt chart for undergraduate project 2. And this is my reference That's all for me. Thank you for your time.